So, this is going to be the second part of 1.1. This is the last day that we're going to be focusing on these sorts of problems. And today, yes, if you looked at the notes, we do have word problems. You're going to be fine. It's only one-step word problems, but you do need to be able to work through these things. So it's important to be able to take a real-world context and apply it. But, cool thing, notes will go quick. So, let's do this. Example 1. In the 2012 Olympics, Usain Bolt, fastest man alive, won the 200-meter dash with a time of 19.32 seconds. Write and solve an equation to find his average speed to the nearest hundredth of a meter per second. And that's going to be 2 decimal places there. So have your calculators at the ready. Now, what I always recommend when you're going through word problems is pull out the important information. First and foremost, always start with what's being asked. What are you asked to do? So in this case, it's write and solve an equation. So this is what we're asked to do. I'm going to highlight or underline that. Write and solve an equation. Now, what do we need to do with that equation is to find the average speed. Here's the really cool part, to the nearest hundredth of a meter per second. So, meter per second. That's what's really going to give us our answer or our label at the end. So, we can just tack that on, we should be good to go. Now, let's see, how do we actually do that? So, Usain Bolt won the 200-meter dash with a time of 19.32 seconds. Okay, so I'm going to underline the important parts here. Important parts are typically you want to go with your numbers, especially here I see meters and seconds have to be in our answer. So they should be important and hopefully we can find them in our problem. Well, here I have 200-meter dash, so we know how far he went. We know the distance that he ran. And so that's meters, and then per second, well, that's a time. And I see seconds right here. So I'm going to block that off. I should block this one off too. So those are really important labels that we can use, and it's going to help us figure out what we're actually doing here. So if you don't know, there's a very simple equation out there that's labeled as D equals R times T. Now, and that might, just looking at it, might be really weird, but what this really means is distance equals rate times time. And this is going to be what we're going to actually use to solve or create and solve our equation. Now, hopefully this makes sense. The rate is the speed that you're going at. And notice that's also what we're trying to find. So that's good. So rate, think if you're driving in a car at 25 miles an hour for 2 hours. So 25 miles an hour for 2 hours, you're going to go 50 miles. So 25 times 2 is 50. Let's say you're driving at 50 miles an hour and you're driving for 4 hours. So 50 times 4, you're going to end up going 200 miles. So that's exactly what this is really saying, and hopefully that little example makes sense in your mind. So now back to the actual numbers that we have here. I want to fill in everything I can in my equation. So do I have a distance? Well, I do have, it was 200 meters, the 200-meter dash. So instead of distance, I'll put label that as D for distance and substitute that into my equation. And I have my equal sign. Rate, do I have the speed that he was going? No, I don't, because that's what I'm looking for. I'm trying to find his average speed. So we can't know the average speed before we find it. So I'm just going to keep that as R for my rate. So that's the rate that I'm looking for. And then I have time. And we definitely have time here. It's 19.32. So I'm multiplying this by 19.32. That's my time. I'll label that as such. So notice that this is in seconds and it's pertaining to his run. The 2012 That might be a time, it is a year, but it's not applying to hit this specific run, so be careful about that. Okay, we have our equation, so there's the first part, write down our equation. Second part is to solve the equation. Well, I have 200 equals r times 19.32, and I want to solve the 19.32, or solve for r, the unknown, the speed. So how do you get rid of that 19.32? Think about it, take a moment. Hopefully you said we're going to divide because we are multiplying by 19.32, so the inverse operation there, I'll do this in a different color, is to divide by 19.32. If I do that on both sides, I hold equality, and that's what I really need to do. So what we do on one side, do on the other, and that gives me r, the thing left over, because my 19.32's cancel. What's 200 divided by 19.32? I want you to type that into a calculator, just as I am going to. And let's see, you should get a big long decimal. But remember, I only want 2 decimal places in my answer. So I'm going to round to the second decimal place, which is 10.35. Hopefully you got the same thing. If you didn't, try that again. But there's one final thing that I will never let you get away with, and you will have to deal with a lot. What is this missing? This should bother you. If I say, what was Usain Bolt average speed? And you just say 10.35. I'm going to go 10.35? What? I don't, 10.35 miles? 10.35 days? I have no idea what we're talking about. You need to tell me. And that's where the rest of our problem, the thing that we underlined before, comes in. So this is 10.35. I'll write this in a sentence. It's nice to summarize it in a sentence. So Bolt ran at, this is his speed, 10.35 meters. I'll abbreviate this. You could write it out too, but M for meters per, I'll do SEC, for seconds. And that's going to be your first problem there. So utilize the labels that it's asking for, and you really can't go wrong. So that's going to work out. Notice on this side, when we did the division, this is a cool thing that's going to help us out later, we have 200 was the meters, and the 19.32 was seconds. So this is the meters per second. And that's exactly what our label ends up with. So that's actually a really cool thing that we know will help us out. So use that if you can. You let the label help you. There's your first example. Second example is on January 22nd. Let me scroll that up. January 22nd, 1943, the temperature in Spearfish, South Dakota fell from 54 degrees, a little chilly, at 9 a.m. to -4 degrees Fahrenheit. -4 degrees at 9:27. How many degrees did the temperature fall? Okay, so that's really cold. Anyway, how many degrees did the temperature fall? So we're looking for the total degrees here, but it's how far did it fall? How would we? What operations do we have to do thinking about this? So if let's say I'm standing at the top of a cliff. I shouldn't use me as an example here, but whatever. If I'm standing at the top of a cliff and I fall, but not the whole way, the cliff is 100 feet high, and I fall down to 90 feet high. How far did I actually fall? Hopefully you're saying 10 feet, which fortunately is at least survivable. So what did you do there? How did I get 10 feet? Well, I had to take that 100 and subtract the 90. That difference is how much it actually fell. So the highest minus the lowest. So that's what we're going to do here. How many degrees did the temperature fall? So I'm going to take my temp 1. I'm just going to give ourselves a little equation that we can work with. Temp 1, our starting temp, minus our second temperature should equal our total change in temperature. So the temp, I cannot write apparently. The temp change, I'm just going to write that as temp change. And that's what we really want. So the temperature 1, what did we start with? Well, that's got to be 54 degrees. So 54 minus temperature 2 was -4. I'm going to use parentheses. It's always a good idea to use parentheses when you substitute something in, even more so when it has a negative sign in it. Equals our temperature change. So I'm just going to label that as T for just a regular T, our final T that I want for right now. So, well, T's already alone, so that's nice. We don't actually have to solve for it. What's this? What's 54 minus a negative? Meaning, really focus on those signs. What's minus a negative? Hopefully you're saying plus sign in your head. So minus and negative really means plus. At my old school, I actually used to call this a Jagunda plus. If you need to remember something that weird in order to tell you that. Minus and negative is Jagunda plus. So anyway, this really ends up being 54 plus 4, and that gives you 58 equals T. So T was our final temperature. How many degrees Fahrenheit did it fall? So summarize it. That's one quick sentence is all you need. So I'll even abbreviate. The temp fell, 58 degrees, and this was in Fahrenheit. So I don't know about you, but that's crazy. 58 degrees, and look how shortly it happened. It happened in 27 minutes. That's more than 1 degree every single minute on average. That's just insane in my mind. So, anyways, that's gonna be it for word problems. Try out the back of this paper. There's a bunch of problems to be practicing and working on, and if you have any questions, let me know anytime.